In this video, I want to show you how a computer works at the lowest level. Computers are no more than mechanisms that transform signals. For example, imagine we have an input here. The computer will do something with it and produce an output. For example, we could have a keyboard. The keyboard will generate an input and the computer will generate an output that can be, for example, a signal to produce an image in a computer screen. This is the overview of how computers work. But how computers do this? Well, computers are no more than electrical circuits. If you remember the basic circuit from the high school, when you have this is a power supply, you have a resistor, you have a switch here, could be open, for example, and you can have here a bulb. So when the switch is open, you don't have light here. If you close the switch, the light uh, produces light. Okay, the bulb produces light. So this is the basic. A computer works more or less like those basic circuits. So what are the signals? Remember that we have the computer, something that receives a signal, an input, and produces an output. Okay. What are those signals? Those signals, imagine you have a wire here from we from where we will receive the signal. Uh, you will have a voltage, and the voltage will vary over time. If this is time, imagine that computer works at 5 volts, for example. You will receive, for example, 0 volts here, and at some point you will receive 5 volts, then 0 volts again, then maybe 5 volts during two intervals of time, 0 volts, and so on. So the voltage will vary over time, and this is the signal we are receiving. Remember that the voltage there is no there is nothing no an absolute voltage. You always measure the voltage between 2 points. So when we are talking about 5 volts, we mean between between the wire and uh, the ground voltage. This is the ground voltage that is equivalent to 0 volts. So all our circuits will share a common ground, and this will be 0 volts, and we are measuring this, the voltage between the wire and the ground. This is the voltage of the signal. And the output is the same. We will be outputting a signal measured between the wire, the output signal wire, and the common ground. And how can a computer perform operations with that signals? Well, the trick is that computers do Boolean operation over the signals. Remember, we are working with digital computers. We only have two signals, the equivalent to 1 and 0. The 1 is the usually is the high voltage. When we, for example, we were talking about 5 volts, this will be a 1, and the 0 will be the low voltage, will be in 0 volt. And we are only doing Boolean operations. Boolean operations are not, and, or, and other operations like NAND. NAND is equivalent to a not of an AND, NOR operations, and so on. But we are always combining Boolean signals, 0 and 1. So, for example, how how can make a circuit to perform a NOT, the simplest one, the NOT? Well, imagine that we have here a point at 5 volts. This is 5 volts. We have here a wire, we have a switch, open switch, a resistor here. We always need a resistor, and the ground. This is 0 volts. 0 volts. Okay, so our output signal will be this one from here. This will be the output. And remember that we measure the output, uh, the difference of voltage between the output and the ground. So if this switch is opened, the voltage here will be 5 volts because we don't have current between this point and this point, and this will be the same as measuring the voltage as here. But if we close the door, we close the switch, then the current will we will have electrons circulating between the 5 volts and the ground, and it will be the same here. No, we will have 0 volts because in this case it will be the same as measuring here, measuring at this point. Okay, this is more or less the basic mechanism. So the trick, let's draw it again. The trick here is the switch. Okay, remember this is our output. This is 5 volts. This is 0 volts. This is the switch, and the switch is activated by our input. So if we have an input here, then imagine that this I'm gonna drop this way. So this switch is closed when we have here 5 volts, 5 volts, sorry, and is open when we don't have voltage here. So what happens? Okay, if we receive a 1, remember a 1 is 5 volts, then this will be closed and the output here will be 0 volts. So we have a 1 as input and we have a 0 as output. This is the anode is inverting the signal. And if we have a 0 here, then the gate will be open and we will have here 5 volts. So this is equivalent to a 1, and we are inverting the signal. So with this trick, with this door, this switch, okay, this switch that is electrically activated with the input, we are performing a Boolean operator, a not operator, a not operation. The output we could this output could be the input to another circuit, and we could make combination of circuit. But a simple circuit is just that. A voltage with a resistance, an electrically activated switch, and a common ground. And with that, we can perform Boolean operations.